All right. Thank you. So I'll do a survey. How many of you know what an IXP is? Wow. Love it. I did that before. And at the end, I asked the same question, and there was only 2 hands that went up. So we'll see how that goes. So today I'll talk about Internet Exchange Point and why it's important in Canada. So a little bit about CIRA. So CIRA, we're the Canadian Internet Registration Authority. Does this work? I gotta wear this here or more stuff? I was almost sampled. 1, 2, 1, 2. So we're Canadian Internet Registration Authority. We run .ca. Everything that finishes with .ca, we're the operator behind it. We run the registry for .ca. We have 2.8 million domain names. We have a global DNS infrastructure. I'll talk about that. And then we have cybersecurity services that we leverage our global DNS platform to sell more services on top of that. And we have people here that will talk about that at the end. And we also in the registry services. So if you want to do .canata, whatever, we would be the backend operator to run that on your behalf. Just talk to me or anybody here will do that. And then we do a lot of good stuff for the internet. We give money away, $1.5 million a year. We give for cybersecurity initiative across Canada. So .ca, we have pretty much every internet user on the planet is a user of .ca because one time in their life they'll type .ca and they'll go to one of our machines to resolve that name. So we're part of the global internet infrastructure. So I'll talk about, today the focus is talk about Internet Exchange Point, the plumbing. And when we talk about plumbing, we talk about anycast, we talk about DNS, we talk about autonomous networks, we talk about clouds. So that's what at the end, you should understand what this means when we operate 3 clouds. We have 5,000 peering, direct peering relationship with other networks. We have unique peers, and we buy transit. So we peer and we buy transit, and for a lot of people, there's confusion around that. And hopefully at the end, you'll understand what this means better. So .ca, we have a global anycast infrastructure. We have 2 clouds. We have more clouds than that, but these are the 2 that we operate. We have sites around the planet. And anycast, the beauty of the internet is that you can advertise the same IP address in multiple locations around the world. So Google, they got the web server for Google. It's the same IP address that's everywhere around the planet. And then when you're somewhere, you connect to the closest instance of that. And that's the plumbing, that's the connectivity, how stuff happens in the background. And we leverage this across the world to deliver .ca services. And a lot of other people are now starting to build the infrastructure to support the global internet to be more resilient and connected more globally. So the goal of .ca is to serve all Canadians in Canada. So if you type a .ca domain and you're in Canada, I want you to resolve that domain name in Canada, not go anywhere else around the planet to resolve that name. And that means people need to interconnect together in Canada to resolve that name. So networks need to be connected together locally. And then the more connectivity you get, the more resilience you have for the internet. And then over the last 7, 8 years, CIRA has been working with a lot of different people around Canada to build a better Canadian infrastructure with Internet Exchange Point. So to explain what an IXP is, an Internet Exchange Point, you need to understand the basic 101 of the internet. There's transit and there's peering. There are two totally different pieces of the internet that people confuse to be the same. So internet transit, that's something you pay for. So at home, when you buy transit, from your network, you have the ability to send a packet anywhere. So the transit is for you to send a packet anywhere on the planet. So that, you can do that. The packet is free to go anywhere today. So you get an internet connection, you send a packet, it'll go anywhere. The challenge with transit is what you pay for is for someone to send you a packet, you need to advertise your network. So you pay the ISP to advertise your network globally so that when somebody sends that packet, they can go anywhere, they can reach you. So you need to advertise your network out, and that's transit. So you have to pay for transit. So if you have one connection at home, your IP address is advertised, it's reachable by the world, and the packet can make it to you. So transit, you pay an ISP to reach entire internet, and for the entire internet to reach you. And you pay for that monthly fee, $10, $50 a megabit per second, or whatever you pay, for. So typically, offices, they have one connection. You buy from your telco, and you get what you get from Fibre Noire. But from Fibre Noire, you want to buy more. You want to buy 2 connections. You want to have redundancy. But if you, for example, from Fibre Noire, if you buy 2 connections from different ISP, one and the other one, and somebody decides to DDoS you, so if you have 2 100 meg connection, or 2 10 gig connection, or 2 100 gig connection, it's not going to help you if you have a terabyte per second DDoS attack. So the Mirai attack, the latest IoT-based DDoS attack are in the terabit per second range. So it's like 1.2 for Mirai. So that's a lot of traffic coming in. And even if you have 10 connection at 100 gig, you still get saturated, then you go offline. So in the past, having 2 internet connection was high availability. Now you need to do more. And that's why IXPs are important. And this, the recent changes in DDoS attack, the scale of them, made a lot of the internet service provider, a lot of the content provider, change their strategy to connect to the internet. So peering, so transit, you pay for it, and you can reach the whole world, and you can go, the whole world can reach you. Peering is different. Peering is local. Peering is an agreement between 2 networks to interconnect together. So if you have your network here, and you want to peer with us at Lansdowne Park, we run a cable from here to Lansdowne, that's peering. So if I send a packet to Saint Jean, it's going to go through that link directly. That's peering. So if you have 2 kids that want to Skype, and one kid is on Bell, on the other seat, the other side of the street is TELUS home, you run a cable across the street, they can Skype directly. That's peering between 2 networks. Peering can be free. You don't pay per bit, you don't pay per transit, but it's connecting 2 networks together. And then these networks have internet access all the time. So if you cut that cable, if you cut that peering, traffic will still make it through the internet, but it's going to be slower. It's going to be less resilient because you only have one connection. So it reduce latency because direct connection, and increase the resiliency. That's my pitch. Today, in the back end, when you buy transit from Telco 1, and you buy transit from Telco B, except Fibre Noire, they're well connected in Canada. But typically, the Bell, Roger, some of the ISPs will peer together in the US. So if you send an email from one ISP in Canada to another network in Canada, and these networks are not peering in Canada, traffic will flow through an internet exchange point in the US. So a lot of Canadian traffic flows in New York, Chicago, Seattle. You can research that. That's what we're trying to change. We're trying to build more infrastructure in Canada so that this traffic that goes Canada to Canada stays in Canada. Kind of important. So if you have this one location and you have more than 2 networks that want to connect and then exchange traffic together, then you need to have an internet exchange point. So that's the point where all the networks connect locally. So you call Fibre Noire and you say, I want to connect to the IXP. So they'll run a fiber, they'll sell you one. You call whoever, they'll connect you. You put your equipment in a data center, like a pure colo, you have a direct connection to an internet exchange point. So if you have more than 2 networks, that's how you need to have a point where you interconnect. And that's an internet exchange point. So everybody knew that when they raise your hand? So an IXP is super cool for some things. So if you have your network and your employees VPN from home, and you have an ISP that only accesses the internet through the US, and then you VPN through the US, back to another network in the US, up in Canada, across the street, that's why employees complain often. VPN is slow, it doesn't work, I keep getting disconnected, you lose a packet, everything goes down. An internet exchange point allows your enterprise network and the local ISP to be interconnected together so that the VPN connection is direct. And that, in Toronto, Torrix, a lot of people leverage this. People work from home. This is the primary connection, super fast, low packet loss, works fine. And then if the internet exchange goes down, doesn't matter, still go through VPN. But through the internet, the real internet, and it breaks. So like the real internet and this, around the planet, there's about 1,000 internet exchange points. Take all of that together, that's the internet. So when you build an internet exchange point, like we're building in Ottawa, you're actually building the internet in Ottawa. So people use the internet when you have transit only. This is the internet when you peer locally and exchange traffic. That's what the internet is. When network connects together in one region is the internet exchange point. So peering is agreeing to exchange traffic with other networks. And all you pay for is the connection to the IXP. You don't pay for transit. But here, your packet can only make it to the local participant. So the packet doesn't go everywhere on the internet. It only stays local. And everybody can send a packet to you, but they need to know your route. So you need to agree with other networks to exchange traffic. So I think that's high level. That's what you need to understand or know about an IXP. Is it brings local connectivity together. You connect network. And across Canada, across the world, people are building more and more of these networks. Here's where it gets really interesting. Is once you build an internet exchange point, you actually build a piece of the internet. Once you build a piece of the internet, it's an ecosystem. People will start coming around. So if you build an internet exchange point, Zero will go. I want .ca to be resolved locally in Ottawa or at that internet exchange point. The government of Canada is going to want to connect. Is that me? No. Okay. Because the internet and the transit and the DDoS attack and all the bad stuff, is there a pointer? Because of all the bad stuff that happens on the internet, the content service provider are now changing their strategy. Instead of having a big thing somewhere in California to serve all of your content, the content providers are moving to a local cache near an IXP. So for example, in Ottawa, Cloudflare is a content provider. So you can use their services for them to host your website, to provide more resiliency, and they do tons of cool services. So Cloudflare, instead of having a huge farm in California where the headquarters is, they deploy a cache. In a rack, they'll put servers and equipment. They'll leverage the Anycast technology. They all have the same IP addresses. And they connect and peer with all the other participants of the internet exchange. So content providers, the Akamai, I think the largest content provider is Akamai today. They have the largest cache, the most customer, and they connect an internet exchange point. And then from there, oops, what the heck? From there, the local ISP can reach the traffic directly. You can reach Amazon directly in Toronto from if you peer connected directly. So the content provider are now globally installing more and more of their cache near Internet Exchange Point to serve users more directly. So the name of the game for content delivery is is to be as close as possible to the eyeball, to deliver the best service, to be the more resilient to their delivery of services. So if you have a community, if your network is connected to an Internet Exchange Point, and you can resolve .ca, you can resolve all the DNS you need. Locally, you can access Akamai, Amazon. If the internet, all of the internet goes down because there's cyber attack and warfare and whatever, this stuff is going to work local. The local piece of the internet in Ottawa with this Internet Exchange, for example, and all these participants would mean that technically you'd be able to do Netflix, which is super important, apparently. If Netflix was here and their cache was here, you'd be able to stream locally all of this stuff with a little piece of the internet without needing to reach the rest of the world. Yep.
So this may be more of a macro than one version, but so once Ottawa has an IXP, how do I know that I'm choosing a local ISP that is connected to it? Because if they aren't, I don't get the advantage.
So on the IXP website, we list all the peers. So today, if you go to, for example, Vanix or Kix, or I have the different site at the end, but you can see exactly who peers. Yeah. Not everybody peers, and that's a problem. But that's a different slide deck. Yes?
Yeah, what about the dark?
The dark net is just something that runs here. It's a Tor network. There's a bunch of people that run stuff that encrypt data. And they have their own thing on top of the internet. Don't go there, it's bad. So this makes sense? This is where, so large IXPs in the US have all these content providers. Toronto's got most of these people in there. Netflix, I put it there because you can relate to that. But they don't actually have caches in IXPs in Canada yet. Everybody would like to have it, but that'll come over. Yes?
Question is, just thinking, I don't know. Is the dark net internet just that part of the internet if you don't have DNS servers on?
It's got its own DNS resolving system,
Yeah.
.onion, and all the domain names are .onion.
Yeah, and that's the only way to reach it. That's pretty the only difference between dark and the rest of the internet.
Well, no, but it's a topic. Maybe Boris can do a slide deck on that. A lunch and learn on that stuff one day.
I guess we're gonna move on then.
Yeah, that's totally different discussion. This thing is. So this is physical connectivity, local networks, making the internet better for a community. It's really important because if your network, if you have a network, if you have a business and you exchange tons of data with another business in the same region, you shouldn't buy transit. Both companies should not buy transit. You should exchange data. And so the main reason also for like autonomous driving system. If you have an autonomous system that has ISP A that does one part, ISP B does a second part, another one does telemetry, they're all different ISPs, and then they exchange traffic in the US, it makes the latency super long. It makes the resiliency bad. So if you do stuff like that, you should mandate that people peer locally, exchange traffic locally, and use the internet in case the IXP goes down, but leverages the IXP for primary connectivity. So if you come out of here with anything about IXPs, an Internet Exchange Point is the internet. It's not an addition to the internet. It is the core internet, and it's supported by the rest of the networks to provide connectivity. Because the internet is a network of networks. That's all it is. Speed, resiliency, quality, there's probably less packet loss here, you can control it. If you exchange traffic with me and you lose packet, the only person you can complain to is Boris, who runs the IX, or me, my router. You're not gonna go in talking to in Ashburn. If you're on Bell, I'm on something else in Canada. It's gonna go in Ashburn, a bunch of routers. You don't know where to fix the problem. Yes.
In Canada, who are IXPs? Like, can Bell be an IXP? Like, can they have their own side business and operate as an IXP, or?
Yeah, that's the slide I'm missing, I think. An Internet Exchange Point usually is a non-for-profit organization. It's supported by the local community, typically volunteers, or if you're big enough, you have full-time. But it's an organization that all they do is they run the Internet exchange, the switch. They run a community around it to support it, and it's vendor neutral. Has to be located in a vendor neutral location. It cannot be in Bell, for example, because Bell will not allow Hurricane Electric and Tata to exchange traffic in their facility. It has to be vendor neutral facility.
If I can just do a quick aside, I wanted to say that Gibson Law is actually the most secured ISP in Canada, and that information is public and is available through Hurricane Electric, and we do here at IXPs in Ottawa, Toronto, and Quebec. So that's many of us very much.
Yes.
Do you know roughly how much Canada's traffic is routed through in IXP outside of Canada?
32.5? I don't know. Somewhere around there. It's like 30%-ish. It depends on who you use and what measure, but it's too much. Oh no, I mean, from Canada to Canada, 30% of the traffic flows in the US. Going out, I don't know. It depends on. I would say most of the traffic stays within Canada because most ISPs have access to Google, Netflix, Facebook Cache are all in Canada. And that's 90% of the traffic. That's, yeah. .ca, all we do is make cat videos work. Now I'm depressed. So nonprofit, this is the internet, and that gives you access to the rest of the internet. Super important. So if you build something in Ottawa and you want a bunch of you to work together and make a cool system work fast, efficient, resilient, connect, peer locally, you're creating the internet in Ottawa. Yes?
I had a question regarding the local content side. Who takes into consideration the caching and scale caching?
The vendors, they take care of that. So Cloudflare and Akamai and Google, they all manage their own. So any more questions on this? This is the right time because this is, so an IXP is a switch. It's a layer 2 switch. And the only feature we need on the switch is to support 100 gig ports, 10 gig ports. We don't like 1 gig ports, that's posse. We need MAC address security on the switch to make sure that the port connecting is connected to the right router and it can't be spoofed. We use route servers to advertise routes, BGP routes. All the magic happens with BGP. I'm not going to talk about that too much.
Maybe explain for everybody, if IXPs are extremely successful and similar to what we see in the US, what's the end user results as a normal internet user in terms of costs and things like that? Like, what happens to Canada versus what it is now?
Cost? In the beginning, we thought it would reduce the cost of users, but it doesn't. Typically, ISPs keep the same costs, but it makes them better at increasing their infrastructure. So what happens is, like a Winnipeg is a good use case. The local wireless ISPs, they had access to transit from here, from tier 1 internet transit. So instead of paying $50 a meg, they paid 50 cents. So the cost saving, they bought better infrastructure for their user. They were able to become more competitive. So that made the landscape better. It made the user much better because now users were streaming from Google direct from the cache instead of streaming to the US and transit. And then if this fills up because somebody's messing with your internet pipe, you pay for like a 1 gig connection costs some money. Here you can have 100 gig in Ottawa. You're just a fiber, dark fiber. You run it, you have 100 gig. You can have as much bandwidth as you want to exchange. So the performance of your network with these services, much better. So if everything you do is Amazon, you should peer at Toronto and connect to Amazon directly instead of through transit. Transit is backup. Peering, primary. And that's, the entire internet is changing to be like this. So this is happening right now. And in Ottawa, we're building this. Okay, so what I'll do is I'll talk about the landscape. So not long ago, 2012, Canada, we had 2 internet exchange points. And that's probably why most of the people don't know what an IXP is around the country. They don't know how to leverage IXPs for their business, how to build cloud services, how to build really cool stuff. So this slide deck I can make available as a PDF to everybody after. So this is not long ago. So that's when I started at CIRA in 2011. Part of my job, CTO, I travel around the world. I meet all the other countries. We do ICANN meetings, DROIT meetings. Everybody's talking about internet exchange points. And I go like, what the heck is that? I've been CTO of a public company forever. I never knew what an IXP was. Then I go on the internet, and then every countries have IXPs, and then I check, we only have 2. Torix is big, Audix is super small, like you can't even connect with, like, what's going on? So CIRA, what we did is we started a program to communicate the need in Canada to start IXPs. So we don't run them, but we said, hey, we need more IXPs in Canada. This is what we need to do. So we looked at Calgary, MBIX is Manitoba Internet Exchange, Montreal, that were added in 2013. So it took us a year. We added 3 internet exchange points in 2013. And then the 2 years after that, we added Vancouver, Edmonton, and Halifax. So we added an infrastructure. So building an internet exchange point means we go to Calgary, we do a town hall like this, we explain what an IXP is, you're all network operators, and then we say, who wants to volunteer to be governance? Then, okay, pick 5. Who wants to be on the operation committee? Pick 6. We did this in Ottawa 3 years ago. And then that's how we created the Internet Exchange Point. People, the community support the Internet Exchange Point. It's not a business. The Internet is grassroots infrastructure like this. 2017, we added the Saskatoon Internet Exchange. This is where everybody said you'll never put an Internet Exchange where SaskTel controls the entire province, and it's impossible. And it's the second fastest growing, I would say, in Saskatoon. Once you bring Tier 1 in Saskatoon, less expensive transit, you have connectivity option. People start to build businesses to run fiber. People build colo. It's an ecosystem, and it's actually working out. We're expanding to 2 sites. There's a river in Saskatoon. There's north-south. So we're interconnecting both sides of the cities together. So this is good news. 2018, Atlantic Canada, they like to have Internet Exchange Point. We're at there's 4 now. But it's there's a need. Audix, 2018, it went defunct. So for an Internet Exchange Point to work, it needs to have a community. It didn't have a community. It needs to be in a vendor-neutral location. It wasn't. They started at Primus, and they got bought by Roger. They moved to, what is it, another site on downtown, Atria Data Center. that got bought by Roger. They moved over the course of its life, the Internet Exchange, AUDX, moved 3 times. 3 times was acquired by telco, and that breaks. You can't run your fiber there anymore, and it died. So at the same time, we said we need, because there was no community, we did a town hall, and we started the Ottawa Gets No Internet Exchange. So that's the one that we have here. Atlantic Canada, they started the PEIIX.
Potato exchange.
Yeah. But you know why they started an exchange there? It's an island. There's 2 fibers that go in on the bridge. So when the fiber gets cut, what happens? No Netflix. And worse, to connect to Netflix, you have to resolve the root. You have to resolve .com. You have to resolve Netflix.com. Then you can connect to the cache. So when the fiber cuts, you need to have root servers. You need to have .ca, VeriSign servers. You need to have the Netflix servers to be able to connect. Yes?
So it's really interesting. I'm watching the natural, this is just the natural order of adopters that kind of came in over time to the IXP. There's a couple of interesting, I'm just wondering, first of all, is there a relationship between the early IXPs, the orange ones, and then the purple ones, and I think it's the green and the black? Is there a correlation to bandwidth and hookup speeds that they have?
There's a relation. I would say that
Does it get less and less?
there's more and more bandwidth available to the community.
So, but in the point, are they IXPs, are they attached as an IXP with higher bandwidth than say the purple?
So connecting to the Internet Exchange point. No, they're all different. So in Saskatoon, they connect with 1 gig and 10 gig connection. And I think the minimum we have for Ottawa Gets No is 10 gig. We don't accept 1 gig connection. 10 gig is the default. There's lots of technical issues with buffers and switches and losing packets and all that stuff that can talk to, I'm sure most of you know that. So cool.
Sites are coming online as IXPs, it's kind of the same order that the typical layer down the line.
So there's a maturity of the internet community, for sure. Some are more advanced or more ready than others. I would say the biggest blocker for an internet exchange point is how big the incumbents are present in a location. So Ottawa is the worst city of all. Like since the beginning, we've been trying to set up an internet exchange point, and we always, it has to be vendor neutral, and Ottawa is not vendor neutral. So finding a vendor neutral location is much harder than getting the community together to work on this. No, I get your point. I think there is, it depends on the people and their willingness to, because this is all volunteering. They're all volunteers doing all of this. Torix has a fabulous group of people, technical people that supports the switches infrastructure, all volunteers. The internet is not regulated. There's no regulation here at all. To do what? No. Well, we want to get the government to connect, participate, and exchange traffic. So here's the government of Canada only uses Bell for transit, let's say. And Bell only peers in New York, Chicago, Seattle. So if you're not with Bell and you file your taxes through the US. So we want Bell to peer and exchange locally with all the transit, and that's the next phase of this, is once we have coast to coast people, and people like you understand, when we say we want Bell to peer, you understand what it means now, because peer and transit, two different things.
Yeah.
Oh.
Yeah, I guess the question was also the capacity limit of these ISPs, like power supply or total pipe, in and out. Because most of them are scalable or scalable to certain limits. Anyway, you can't take it more pipe or pipe.
Because there's a port fee to connect, the Internet Exchange collects revenue to operate, and all the business case around the world show that I don't think there's a limit in scalability. HAM6 is how big?
They all know very well, and they have like traffic against security, and based on the data center kind of fabric concept that we hold in the last 5 years, there is eventually more than the limit. The hyperscaler have sorted that out, so basically they run that with for sure that you will get that TLE. So power is not actually a problem. It's really
The biggest problem we have is people knowing IXPs exist and connecting to leverage the value.
Is it the CDNs that jump on IXPs immediately? Like when you set up an IXP, who are the first participants to the besides the users?
The volunteers?
Who provides services to those IXPs? So is it CDNs that jump on
Okay, so
first?
in Ottawa for AUGIX, the first one that showed up is Cloudflare. So they're at Pure Colo. I don't know if that was public or not. No,
As long as it's not on a web page anywhere, we're fine.
but the content provider, I met them. I meet everybody. Like next week, I'm going to Africa for an ICANN meeting, and I talk to everybody about this stuff. And I say we're going to build an internet exchange in Ottawa. They ship equipment here. They have the content. They got the equipment. The content provider is present before the internet exchange is launched. So people, this is the way it works. People build it and they will come. We're building it, except all the connectivity issues we're having. Ottawa's too big and decentralized, but it's going to work.
They'll also create their own paths as well to other hubs. So when they come in, they'll architect their own traffic to Montreal Internet Exchange or Toronto Internet Exchange, depending on which one they
They're
want.
kind of sponsoring for the equipment and stuff.
Correct, yeah.
The interesting one, the last summer and this year, we've been working on Arctic IX, which is in Iqaluit to start. And the problem is their satellite. Everything they do is satellite. It's 700 millisecond, one way. There's nothing there. All the different networks have their own satellite uplink. So the CBC, they generate a lot of content. They store the content on the mainland in Saskatoon, wherever their data store is. And the people in Iqaluit don't have enough bandwidth to stream the content that's generated there. It's a big mess. So we're looking at building an internet exchange point. All we need, we're at the final stage of setting it up. And we're going to connect the local networks together. So kids, when they submit their homework to the school via the internet, they have to pay bandwidth up and down to the mainland and then routed. So they got to go from here to here and then back here to the school because they use different satellite provider to send the data. They pay twice for that, and it's crazy. So an internet exchange point makes it possible to route the local network. So the internet is a IXP. So now we've announced we're putting an IXP there. It's public and everything. Somebody's thinking about running a fiber there because it's an internet exchange point.
The average user speed down and out in the Arctic right now, just so
0, kilobit second. So when I went there last summer, and I don't know if you know this command, I went dig, name server at any.ca servers.ca. So I wanted to know what, I did a query to my own name servers in, to find out what they are over DNS, and it took 15 seconds to resolve a query. So when somebody types a domain name, just to resolve the name takes 15 seconds. Crazy. But there's good fishing, salmon fishing. Yeah. Yeah, people are, yeah, from Greenland. That's the plans. They're working on that.
It's a big improvement on satellite.
Oh, yeah. Well, yeah, you can have gigabits, tens of gigabits instead of mini bits. They, it's local. All the networks are local, but if you're connected to an internet exchange point here, my network that connects here, I have transit to the internet. Akamai, Amazon has transit to the internet. Everything here is connected to the internet. All you're doing is you take the internet, you take all the network, you bring them up, interconnect. It's like short-circuiting the internet, local. But everything here is connected to the internet. So you come, yeah. It's like if, imagine if we all talk together with cell phones, that'd be a big mess. So if we all came to the room here and talked together directly, so we're in an internet exchange. We all talk together, you all understand me, and then if you want to reach out, take your phone, you reach the rest of the world. So this is an internet exchange for people, and we still have access to the rest. This is what that is.
So, as an individual private user, something, do you have to do anything to access an IXP, or is it just automatic?
You need to ask your ISP to connect, please.
So, but when you go type in address, like Netflix.
Oh, so if you're at home,
Like, yeah.
so if you're at home,
Special you have to do to connect to an IXP, or just somehow done in the background?
when you're at home, you open up Netflix. Netflix will look at your IP address. They'll know that you're connected to AUGX, and they'll serve you the content at AUGX. And that's the way it works. Akamai, if you look at the name resolution for Akamai, it's super fancy with A names and C names and stuff. And when you type, let's say apple.com. Apple.com is not even, it doesn't exist. It refers to another name that refers to another name to another name. That is the closest Apple Akamai cache near you. So the name, the DNS, the name resolution, make sure you connect to the closest content on the internet.
So it's transparent to the end.
Yeah, totally transparent.
So you have to just lobby them to get an IXP in your neighborhood effectively.
Yeah.
Yeah, I just had a question about online, about what the saturation point is. Like, is it the goal just one per province, or like how many internet IXPs is too many?
So this is what we're adding right now. In Vanix, there's another one. In Vancouver, there's a second nonprofit internet exchange starting. It's the more the merrier. We'll support all the vendor neutral non-for-profit IXPs in Canada. There's a market, there's competition, great. Price goes down. So the big issues that we have right now that we're working on is keeping traffic in Canada. So we want all the incumbents, all the telco, it's your job to tell Bell, TELUS, Roger, to actually TELUS is connecting now to Internet Exchange in Canada. Doing good job. Bell we need to work on that. Attracting more content provider to Canada. We need to get all the levels of government, municipal, provincial, federal, to connect to the IXP. we need to communicate, as IXP operator, we need to communicate to you the value, the marketplace of IX. It's got to be clearer. So that's something we're going to work on. And the more tier one, so once you build the internet IXPs, tier one, the Tata, the level 3, all the big guys that are core to the internet, if there's enough eyeballs or people or ecosystem is big enough for them, they'll connect, they'll go near the IXP, but they won't connect in peer, but they'll be there and offer their services to the other peers, which makes the internet much better.
With regard to the cost of the IXP, is the IXP just connected to all of the peers by private lines and it gets connections to the internet through the transit bought by the peers?
Yeah, something like that. So peering is connection, your phone to the rest of the world is transit.
And the IXP itself has no transit.
There's no transit.
Shared transit, however the purpose.
It's local. It's this room. Us together is an IXP.
So the total cost is the cost of the lines and the IXP itself, part of which is offset by level.
Yeah, so it's super cheap. Like $1,000 a year for a 1 gig port. 1 gig port per se. That's what the numbers. It's not $1,000 a month. So I don't know if this applies. A lot of people in Canada, they wonder what Suva's role is. So our role is we support the development of IXPs. So we'll go in Regina, we'll have a town hall meeting, I'll buy a bunch of beers, I'll get all the guys and girls together, we talk about IXP, and then hopefully they're going to elect somebody to run their governance and technical committee. We support them in any way we can, but our job is not to start new ones, to operate them, to own an IXP. We don't own any. We don't manage them, we don't govern them, and then we don't rule them. So I'm board members in many of them, and I'm a equal peer, and many CIRA people are equal peers to others.